This video will cover the third page of notes for the topic of log functions and their properties. At the top of this page, we have the properties of logarithms. One thing I do want to note is that they're using the letter A to represent the base. So we know that the base must be greater than 0. That means it must be positive. The base cannot equal to 1. And for any real number k, then we know that the following is true. So we know that if we have the base of 1, the answer is always equal to 0. And we know that to be true because if we get the base and we put the exponent of 0, we will get 1. And that's true because anything to the 0 power is equal to 1. Another one that's very interesting is that if we have the base of a to the k, then the answer is k. Because if we have our base and we put it to the exponent of k, then that's going to equal to a to the k power. So this is true. And finally, we may not see this a lot now in college algebra, but you may see this in other math classes, is that if you have a to the exponent of the log, what we do know is that just like exponents and logs are inverses of each other, they will undo each other. So in other words, a to the log of base a will actually cancel each other out and tell me that the answer is just k. And again, this is going to be true only if k is greater than 0. And like I said, we won't see much of this one, so we're not going to worry too much about this particular property. The biggest properties that I do want you to be concerned about is going to be these three: the product rule, the quotient rule, and the power rule. The product rule says that if you have two things being multiplied, it's the same thing as getting the log of the first one plus the log of the second one. So if you have log base a of x times y, then I can find the log of base a of x and add it to the log of base a of y. Notice they have to have the same base. If we go to quotient rule, we have log base a of x divided by y. Then notice that I'm going to have log base a of x minus log base a of y. Because the y is in the denominator, that's why we're subtracting. If it was being multiplied, that's why we're adding. And the third one is the power rule. That if I have the log of base a of something that has the power, then I can put that power or that exponent to the front. And that's how I have r times log base a of x. So if I have log base a of x to the r power, I can bring that r to the front and have r times log base a of x. Only because we use so much space in our notebook for the properties of logs, you can think about example number 2 and 3 being kind of squeezed in, but we're going to go on ahead and use these properties to either condense or collapse. I can't remember which word is being used in my math lab for the examples in the homework. But when they ask you to condense or to collapse, they're asking you to put it into one log. So notice we have log base 3 of x plus log base 3 of 5. Because the logs have the same base, then I can write this as one log. Because we're adding the two logs, remember from the product rule, if you're adding, then it's the same thing as multiplying those values. So in our case, we're going to have the log of base 3 of x times 5, and that's what you see here. And normally we would write that as 5x. So we use the product rule to find that. If we go to part B, notice we have the log of base 9 of 15 minus the log of base 9 of 7. Using the quotient rule, that if you have a minus sign, then you can write them as a quotient. I am going to have the 15 on the top and the 7 at the bottom because that negative is going with that 7. Remember, that's like a negative exponent causing it to go to the denominator. So that's the reason why I have log of base 9 of 15 over 7. We use the quotient rule here. And finally, let's take a look at example C. For this one, we see that we have 2 times the log of base 6 of x minus 3 times the log of base 6 of y. So we have this subtraction, which means we're going to use the quotient rule. We have this 2 being multiplied times this log, and we have this 3 being multiplied this other log, so we're also going to use the power rule. So I'm going to use the power rule first. So I'm going to bring this 2 to be the exponent of the x, and that's where you see this part. I'm going to leave the minus sign, and I'm going to do the same thing for this 3. I'm going to bring it as an exponent right here with the y, and that's why you see this guy down here. Now I have this minus sign, so I'm using the quotient rule now. So I'm going to have log base 6 of x squared at the top divided by y cubed. Notice I'm only writing down one log, and I have combined or collapsed or condensed my 2 logs into one. For example number 3, our job is to expand into simple logs. And what they mean by simple logs is just log of the base of one little thing. So in other words, we're just doing the opposite of what we did for example number 2. So notice if we look at part A here, we have all of this that needs to be leveled out. So we have a power rule here because we have 2 as a power. We have a product rule here because these two things are being multiplied. We have a quotient because the top is being divided by the bottom. So I'm going to rewrite it so that I just do the top and then the bottom. So I'm going to have log base 3 of x squared times x plus 2. That's where you see right here. And then minus log base 3 of 2 because the 2 is in the denominator. That's what you see over here. Now let's try to simplify this first part. I have the product, so I'm going to change this into the product rule. So I'm going to have log base 3 of x squared plus log base 3 of x plus 2. But I have that, the power says I can bring it to the front. And that's how I have 2 times the log of base 3 of x plus the log of base 3 of x plus 2, and then I still have the minus log of base 3 of 2. And that would finish this particular problem. Notice we cannot change anything here because we only have a product rule that says if you have 2 things being multiplied, then we can do something about it. We have the quotient rules that says that if you have 2 things being divided, then we can do something about it. And then our power rule that says if you have something that has a power, then we can do something. So this x plus 2 actually just stays as x plus 2. Finally, let's do the last example where we have the log of base 2 of the square root of x over y times z. So I said times z because I want you to realize that we have a product rule down here, we have a quotient rule happening, and then we have this square root to everything. So let's divide it up a little bit. So if we have the log of base 2, I can get the square root at the top and the square root at the bottom. And that's what you see here. Now I can use our quotient rule. So the log of base 2 of the square root of x minus log of base 2 of the square root of y times z. So now we can see I have my square roots. So that's the next thing that I'm talking about here, is that I can rewrite those square roots as exponents. So this would be the log of base 2 of x to the 1/2 minus the log of base 2 of yz to the 1/2. So again, we can see that we can move our exponents to the front by using the power rule. So we're going to have 1/2 log base 2 of x minus 1/2 log base 2 of y times z. So now last thing I need to do is to get rid of this product. So I'm going to have 1/2 log base 2 of x minus 1/2. And I'm going to put this in a big parenthesis so you can see what's happening. I'm just looking at this part to expand. So I'm going to have the log of base 2 of y plus, because remember if it's a product we add, log of base 2 of z. And then I can use my distributive property, get rid of parentheses. So I have 1/2 log of base 2 of x minus 1/2 log base 2 of y minus 1/2 log base 2 of z. So remember what I'm doing. I'm getting this minus 1/2 and multiplying it times this log and multiplying it times this log. And that would be our final answer. So I wanted to make sure that I showed you that. I'm going to go back to the reflect for this lesson so that you can see how we can use these properties to solve that. So let's change this into simple logs. In other words, we have the log of base 5 of y squared over x. So we have a quotient, so I'm going to rewrite this as the log of base 5 of y squared minus the log of base 5 of x. I'm going to use my power rule that says that if I have an exponent, I can bring it to the front. So it's going to be 2 times the log of base 5 of y minus log of base 5 of x. So now I'm just going to use substitution. I know a value for the log of base 5 of y, that's equal to 3. So this is going to be 2 times 3 minus, and I have a value for the log of base 5 of x, that's equal to 2. So minus 2. That's going to give me 6 minus 2, which is equal to 4. So that's our answer to our reflect. And that concludes this video.